Part of your goal on this is to be able to put this together without having to do so much with your calculator, okay? So the first thing, a rational function, we talked about what that is you have a fraction, you have a ratio of polynomials. So the first thing we're going to do is look at the horizontal asymptote. I taught you how to do that, but what's different on this one is this. Okay, first of all, can you tell me what the degree of the top of this function is? 3. Remember, that's the highest exponent. So the degree of the top is 3. Okay, the degree of the bottom would be 2. So here's what happens. Anytime the degree of the top, if the degree of the top is larger than the degree of the bottom, okay, then you don't have a horizontal asymptote. What we'll end up having is we're going to have what's called a slant asymptote on this problem. So I'm going to run through and show you how to do that then, okay? And it's got to be 1 bigger. So if that is, and this is worth writing down and just kind of make a note to yourself, if the degree of the top is larger than the degree of the bottom by 1, then you have what's called a slant asymptote. And a slant asymptote is just a line. It's a linear function that'll tell you how the function behaves at infinity and negative infinity. All this stuff with asymptotes is a pretty big deal in Calc 1, and you'll see that when you take Calc 1. Okay, so we don't have one. Now let's look at the vertical asymptote, okay? The vertical asymptote, what we do is we want to simplify this. So you can factor an x out of the bottom. So you want to go ahead and take an x out of the bottom. If you do that, you would have x times x plus 2. Now nothing cancels. X cubed plus 1 does factor. That's a sum of 2 cubes, but I'm not going to bother with that. So basically you have 2 vertical asymptotes. What are they in your head? 0 and negative 2. Good. Okay, because what you're doing is you're just setting that denominator equal to 0. You're trying to find where the function's undefined. So you'd have x equals 0, and you'd have x equals negative 2. Okay, so you do have 2 vertical asymptotes in that problem like that then. Okay, so we got that. All right. Okay, let's go ahead then and let's go down to our graph and let's go ahead and put those 2 asymptotes on here. So you want to just go to x equals 0. You just want to kind of dash the x-axis. Okay, that's going to act as a vertical asymptote like that. Then you have x equals negative 2. So you want to take a vertical line through there, and then that will be your other vertical asymptote like that. Okay? All right, it's good to get the intercepts on here. So the intercepts go like this. When you do an x-intercept, what do? You set y equals 0. In other words, you just do the function. So what you would do is you would do 0 equals x to the third plus 1 over x squared plus 2x. Okay, now you can bypass this step I'm going to show you here, but technically what you're doing is you're multiplying both sides of this equation by that denominator so you get rid of it. Okay, so what you'd end up having is 0 equals x to the third plus 1 like that. Okay, that's the way that you always find vertical asymptotes, is find what values of x make y 0. Okay, well you can solve that equation by doing just isolating x and doing a cube root. So if I subtract 1 from both sides, I would have negative 1 equals x to the third. Then I can cube root both sides, okay, like this. So we have x, okay? Does the cube root of negative 1 exist? Is that a real number or is it imaginary? It's real. I noticed that on your test. There was a problem on there somewhere where you had to do the cube root of negative 8, and a bunch of you said, no, that's unreal. No, it's real, okay? Because if you take the number negative 1 and multiply it out 3 times, won't you get negative 1? So you can do a third root or an odd root of a negative number, so that just gives negative 1. So that would mean that your x-intercept, you only have 1, you have negative 1, 0. So far we've got an x-intercept, we don't have a horizontal asymptote, and we do 2 vertical asymptotes like that, okay? All right, y-intercept, what do? You set x equal to 0. So you go all the way back to your function, and everywhere you see an x, you just plug in 0. So you're evaluating the function at 0, so you have 0 to the third plus 1 over 0 squared plus 2 times 0. Look what happens on this. You get 1 over 0. Okay, what would that tell you about the y-intercept? You don't have one, okay? So you're not going to get any finite value on that, so it would mean that. Okay, so those are kind of the standard things that you do. If you're looking at horizontal asymptotes, You got to look at degree of numerator and denominator like we learned. Vertical asymptote, you're looking at what makes the denominator 0. And then that's the way you always do an x and y intercept like that. Okay? So here's what we're going to do next. Okay, so we have to actually find the slant asymptote on this one. Okay, so let's go ahead and let me show you how to do the slant asymptote. Okay, so what you want to do is you want to do a long division problem. And you can't do this synthetically like we've learned how to do. You got to go like this. Okay, I'm just going to put in x to the third. I've got missing terms, so it's a good idea to put these in. You don't have an x squared, so put in a 0x squared. You don't have an x, so put in a 0x. Then you have a 1 like that. Okay, then we're going to divide by the denominator, x squared plus 2x like that. Okay, so we've gone through how to do long division in here. So we have to do this by long division. Okay, all right, let's run through that and see if you remember how to do that. So you start by doing this. You do this in your head. You don't have to write these steps down. As I'm teaching this, I just want to show you the 4-step process you go through. So you divide that by that. You're going to get x. So you record that x up there. Okay, that's step 1. Step 2, you're going to multiply x by x squared plus 2x. So you're going to do a distributive property, and you're going to record that under the like term. So x times x squared is positive x to the third. X times 2x is positive 2, whoops, I put that in the wrong place. So that's going to end up being positive 2, no, hold on. I've got x times 2x would be positive 2x squared. Now I'm good. Okay, what do I do next? I subtract, right? Okay. So what we want to do is subtract these. Now you can do this in your head. So you do x cubed minus x cubed cancels. This is going to really be 0 minus 2. So that's negative 2x squared like that. Okay, that's the idea. Now what you do is you bring down your next number, which is a 0x. So see, that's the 4-step process you go through. Now we're not done because we can still do one more division, see, okay? So what I want to do from here is I just start over again. Now what I do is I do this thing divided by this thing. Okay, so step 1 I would do in my head negative 2x squared over x squared. So notice that's going to be minus 2. Okay, and then we're going to finish this because I want to explain one little part of this. But right now that's your answer right there. X minus 2 is a line, isn't it? Y equals mx plus b. That is your slant asymptote. Let's go ahead and finish this. Let's do negative 2 times x squared would be negative 2x squared. Negative 2 times 2x is going to be minus 4x. Okay, then you want to subtract, so be careful when you do that. See, here you're doing 0 minus negative 4, so that's going to be 4x. Then you bring down the plus 1 like that. Okay, now this is something you want to know really for calculus. So what happens is the answer to this after you divide is you end up getting x minus 2, and then you take your remainder, which is this, and you put this over the divisor like this. Okay, that's the way you always do division like this. Now here's something that we've learned and you want to think about here. Okay, let's think about what would happen if x was infinitely big. If x was infinitely big, think about what would happen to this part right here. Okay, what's the degree of the top? 1. What's the degree of the bottom? 2. So what happens as that goes to infinity? What did we say the horizontal asymptote was? 0. Okay, so what happens is as you go to infinity, this thing right here just goes to 0. And the reason is for that is because of this. This thing right here is when x goes to infinity, you have a bigger denominator. That denominator is bigger. How come? Because it's got a bigger power on it. So it's kind of like you would just end up having some number over something infinitely big, therefore that goes to 0. So that's your answer right there. So your slant asymptote would be y equals x minus 2. Now you learn a lot more about this in a Calculus 1 class, but that's how you find a slant asymptote. And so what we're going to do on that is we're now going to graph this. That's a line, so it's got a y-intercept of negative 2. So we want to just put this in. I'm going to have you put a y-intercept of negative 2. It's got a slope of 1 over 1. So you want to plot that line then. Okay, so we're going to plot the slant asymptote. So go to the y-intercept, up 1, right 1, up 1, right 1, and then just kind of dash it through kind of like that. As long as you get a couple of points, then you're fairly accurate. So that would be the graph of y equals x minus 2. Okay, everybody with me okay with what I did in long division? Okay. Now what we're going to do is we're just going to figure out without our calculator what this graph looks like. And what will happen is basically this. I can tell you the possibilities. You already know that if you have a vertical asymptote, what does the graph do? It either goes down to infinity or it goes up to infinity, right? Okay? But if you have an oblique or a slant asymptote, here's what's going to happen. Okay, it's either going to just kind of go along and get close to it, and it's either going to be above that line or it's going to be below like that. Okay? Then if you go over here, same thing. You're either going to end up going below like that, above like that, or below like that. That's what we're going to try to figure out without a calculator, basically by doing a sign chart. Yes?
Wasn't our point -1, 0, not 0, -1?
Which point are you talking about?
The red line, you started at
x minus 2. Now, this is your slant asymptote right there. So that's what I... Yeah, that's an asymptote. That's not a part, it's not a part of the function, but it'll tell you how the function behaves when you go to infinity. That's the idea, okay? All right, so what we're going to do is we're going to do a sign chart. Okay, and again, you're trying to learn how to analyze stuff. It's easy to put this in the calculator and see what it looks like. We'll do that in a minute. So what we're going to do is we're going to do this, okay? You always use, in your sign chart, you use vertical asymptotes and you use x-intercepts, okay? So it looks like what we have is we do have I think we had an x-intercept of -1, 0. So what we're going to do is we're going to do this. Okay, we want to have x equals -2. That's a vertical asymptote. We have x equals -1. That's an x-intercept. Then I think we also had x equals 0, which is a vertical asymptote like that. And what we're going to do is, like we were doing last week, is we're going to do test points on this, like that. So always when you do a sign chart on this, look at vertical asymptotes and x-intercepts. Don't look at anything else. That's what distinguishes how the graph changes. Okay, so what we're going to do is we're going to take the function x to the third plus 1 over x times x plus 2, and we're just going to put in test points. Okay, so let's take a test point that's below -2, like let's say -3. Okay, like that. Just plug it in and calculate. So you would have -3 to the third plus 1, then you'd have -3 times -3 plus 2. You know, all you got to do is figure out if that expression is negative or positive. So just by looking, what's the numerator? The numerator is negative, right? Okay, the denominator is a negative times a negative, so it's a positive. So what you would have, because you want to do as much of that in your head as you can, you'd have a negative over a positive, so you'd end up having a negative. That means that what's happening is the graph is below the x-axis. Does that make sense what I did? Okay, you got to use test point. Doesn't matter what that test point is. As long as it's less than -2, it's going to give you a negative value. So here's what's going to happen. The graph, you have no choice. If the graph is entirely below the x-axis, then the only thing it can do is go like this. It'll have like a little shape that kind of goes like that. It couldn't go like that, because then you would have part of the graph above the x-axis. So the way this is going to go is like this then. So let's just kind of sketch that in. You'll have a shape that kind of does something kind of like that. That's it. Does that make sense what I did? Okay. Now we do this on every little piece of this graph. So the next thing we do is we can go out here. Let's go past 0, for instance. And well, it doesn't matter what order we do this in. So if we take a test point like 1, and then again, if we plug it in, we would have 1 to the third plus 1 over 1 times 1 plus 2. Well, what is that, positive or negative in your head? That's positive. Okay, so you can tell that's positive. So that just means you're above the x-axis like that. So that means that when you're to the right of 0, this is basically what's going on in this graph, is when you're to the right of 0, then you're going to have to be doing something kind of like this. You're going to have to approach like that. Now you don't have a y-intercept, so we know at least we're going to be doing something kind of like that. We have to be, all right? Now we need to finish the rest of our chart before we can put this together, but what I'm getting from here is, well, I know that that's going to do something like that because it's above the x-axis, okay? All right? The other possibility, though, is it could be doing something like that, We're not going to really know that until we fill in the rest of this, okay? So let's finish up with a couple of points here. Let's take like negative 1.5. Let me zoom on this just a little bit here. So let's use a test point in here and kind of do the same thing. So what we'd have here is we would have negative 1.5. If we plug that in, we'd have negative 1.5 to the third plus 1. Then we would have negative 1.5 times negative 1.5 plus 2. Okay, well, one thing I can tell on that is the denominator is a negative times a positive. So you got a negative denominator. And then what happens on that numerator, I think that numerator also turns out to be negative. So you'd have a positive. So that means you're going to be above the x-axis like that. Okay, so that's what we know. Does that make sense? How I'm determining that? Okay. Now let's take something here, like a number between negative 1 and 0 would be something like negative 0.5. So again, we plug that in. So what we would do is we would plug into the function. You would have negative 0.5 cubed plus 1 over negative 0.5 times negative 0.5 plus 2. Okay, well, the denominator is a negative times a positive. So that denominator this time's negative. The numerator, if you work that out, I think also gives a positive. If you do that, you could use your calculator to help you with that. So you'd have a negative, so that means you're below like that. Okay, so that's what I'm doing. Now, one thing I'm going to have you do is get your calculator out. So I want to just kind of show you what this sign chart did. Okay, so with your calculator, what I want to go ahead and do is I want you to put the function in. So the function is x to the third, and then plus 1. Again, make sure you have that in parentheses. Then divide by the denominator is on, whoops, I got to close my parenthesis on that. So I do that, and then I'm going to write it, and you can either leave it in a factored form or non-factored. I'm just going to write it the way it originally was x squared plus 2x. That's the original problem that I gave you, was like that. Okay? All right, so I'll have that. And then we want to just do this in a standard window. So once you get that put in, you can go zoom number 6 to put that in a standard window. And let's see if this doesn't kind of explain what's going on in the problem. Okay, well, if you look at the sign chart on this, look at my graphing calculator, well, you can see you're below there, right? Okay, you're above here. And then you're below. So it's below, above, right? So that's what the sign chart told us. Does that make sense? Okay. So what you could do with this, I mean, if you got into a big crunch on this, you can just take test points and put it in your calculator and trace them out. So basically what you would end up having on this graph, from here I'll just have you kind of do a sketch here. So, whoops. So what I want to have from here is you would have something kind of going like this. This part here would kind of go up like this, and then it would swing up and it would approach the x-axis because that's a vertical asymptote. So remember, like we talked about, is if you have a vertical asymptote, which the y-axis is, that's going to approach that, right? So if it's all above the curve, that graph's got to do that, and it's got to approach the slant asymptote. Does that make sense? It's the only possibility on that. It's got to look like that. And then what would happen here is you're above the x-axis in here. So what's happening here is you have this that x-intercept. Remember, we found an x-intercept. Then you just swing up towards the vertical and then swing down like that. So that's how that graph goes. So these graphs right here, when you have slant asymptotes, they get pretty weird. Okay, so that's how you would approach that problem and how you would get that and get a rough graph of that without your calculator. Does that make any sense to you guys? Okay. Do you have something?
We're able to cross slant asymptotes, but we can't do anything.
Yes, and what's important about that is you can cross an asymptote like a slant asymptote. You can't cross it at infinity or negative infinity. So you can cross somewhere in between. Okay, what happens on a horizontal or a slant asymptote is you will never touch it as you go this way forever or go that way. But you can touch in the middle. Okay, that's what happens on this problem. Okay. All right, that's the idea. So let's do one more thing here. And this is something I just want you to put on your calculator. We're not going to do anything with this, but I want to show you kind of what happens here. Okay, so let's put this in. So you'd have parentheses x to the third, and then minus 1, and then close parentheses, and then we'll divide by the x on here, and let's just do that in a standard window. I think you'll probably be able to see this, okay? I tried to make up something that you could see on here. Okay, so here's kind of what happens on this one. If you were to go through, and this is the main thing I want you to write down on here, is the degree of the top is equal to 3. The degree of the bottom is equal to 1. So anytime the degree of the top is bigger than degree of bottom, then you do not have, you have no horizontal asymptote. Okay, but what you have is you have a quadratic asymptote. I'm never going to give you problems on this or anything, or test you over this. I just want you to see what happens. So actually what happens on this problem is this. We're going to go ahead and do long division on this. So let's just do like x cubed, and then I'm going to just put a minus 1 and divide by x, just to show you what happens on this, okay? So what would happen is x to the third over x is x squared. Okay, then x squared times x would be positive x to the third, like that. And what would end up happening on this thing if you went through and did this, it may even be better if I show it this way. If you just split this up into 2 parts, I should just do it this way, then you would have x squared minus 1 over x. So what's happening is this piece right here, as x goes to infinity, that goes to 0. Okay, so what happens on this is this thing just goes to x squared. So if you were to graph x squared, that would be an asymptote. It would be a parabola. Does that make any sense? See, if the degree of the top is 1 bigger, then you have a line. If it's 2 bigger, you have a parabola. What if it was 3 bigger? Then you would have a cubic and so forth. So that's the way asymptotes work. And I mainly just wanted you to see an example of this. So let's put in, go ahead and put this in your calculator too. Just put in x to the second, and I'll show you what happens. You may be able to see this okay if I do this. Okay, yeah, there we go, okay? So that's exactly what I wanted you to see. So what happens is, as we go to infinity, see how that thing just approaches the parabola? If I go this way, it approaches the parabola too. That's pretty cool. Okay, to me it is. Okay, that's the way it works. So again, you can have asymptotes that are not lines. Okay, so I just wanted to show you one kind of simple example on that. Okay, does everybody understand that okay? Just because the degree of the top is 2 bigger than the bottom, that's what makes it have an asymptote that's a parabola. Okay, so that's the idea. Okay, now I don't test you over that or give you homework over that. I just like to show that one time. Okay.